Inverse relations and functions. So basically, we've talked about inverses before, particularly in year 10 when we do trig and year 9, and when we find when we use the sine, the cosine, and the tangent ratios, we can use them to find sides of a triangle. But sometimes you're asked to find that angle that's actually sitting inside the inverse, inside the trig ratio, and we say that, to do that, we do the opposite of whatever tan, cos, or sine are, and we say in this case it's the inverse. So what we're going to be doing is we're actually going to be talking a lot more about what the inverse actually means. So the inverse relation is applying the opposite function that would get you back to where you began. So have a look at these here. We've got a cube and we've got a cube root. So basically how these works, now the cube and the cube roots are inverses of each other. So basically if I put a number into the cube, so like 2, then my output I get is 8. Okay, now the inverse, what happens is, well, if I now take that output, okay, so whatever it was, and treat it as my input and put it into the inverse, then I should get back what I started. Okay, so 2 goes in, 8 comes out, 8 goes in, 2 goes out. Now that needs to work for every single value, no matter what. And when we do that, it's called the inverse. Okay, so it's pretty easy. The idea, anyway. So the inverse relation of any relation is obtained by reversing each ordered pair. So to actually find the inverse, so let's just do this one really quickly. Okay, so y is equal to x cubed. To find the inverse, what you do is you swap the x and the y around, like that, okay? And then what you do is you solve that equation for y. So if y cubed is equal to x, then y is equal to the cube root of x, okay, to get rid of the cubed. Okay, so you swap them around and you just solve it for y. That's it. That's how you find the inverse function. We can try another one. Let's do a straight line. So y is equal to x minus 2. So if I take a number and I subtract 2, what's the opposite? Well, taking that new number and adding 2. So swap them around. X is equal to y minus 2. Add 2 to both sides, and we get x plus 2 is equal to y, or y is equal to x plus 2. Okay, so it is that easy. Like there's nothing tricky really about this. It's pretty straightforward. Now there's nothing tricky about that part. The hardest part is probably graphing these inverse relations. So the graph of the inverse relation is obtained by reflecting the original graph in the line y is equal to x, or in other words, by doing remember the odd function, rotating something 180 degrees or reflecting it. So if you have something here, we reflected it this way and then we reflected it that way. So changing the y and the x around, like as we did, okay? And so, if you have your function that looks something like this, okay, so here's the line y is equal to x. If your function is like a parabola that goes like that, okay, then your new one will be a parabola that goes like this, or something like that anyway. Like that. I don't know. Something along those lines. But we'll look at it in more detail in a moment. Okay, so the domain and range of the inverse relation is literally just the opposites. So the domain of the inverse is the range of the original, and the range of the inverse is the domain of the original. Like okay, so the domain of this one is all x. So then the range is, let's say, 0, y, so everything that's greater than or equal to 0, so like a parabola. Then in your inverse, then the domain is x is greater than or equal to 0, so everything that's bigger than 0, but the range is all y. So you're just basically swapping them around. That's it. That's all it is. Okay, so finding the equations and conditions of an inverse relationship. So let's say that, for example, you've got the y is equal to x plus 2 when y is greater than, when x is greater than or equal to 0. Okay, let's say you've got it like that. Then when you're finding the inverse, when you swap everything around, you're literally swapping everything. So when you go x is equal to y plus 2, where y is greater than or equal to 0. Okay. Then you solve this, and then you do some other stuff, which we'll talk about in a moment. But basically, you have to swap everything. Now, testing graphically whether an inverse relation is a function. Okay, so not all the inverse. So if you do an inverse of a function, if you have a function, then its inverse may not necessarily be a function. Okay, so the way we're going to test graphically is by doing our tests, our vertical and horizontal tests. So if a function passes the vertical line test, then it is a function, and it is a function. If it fails, it's not a function. But if we have our function and we test the horizontal line, or we use the horizontal line test, if whatever functional relation we do passes the horizontal line test, then the inverse of whatever our relation is will be a function. And if it fails the horizontal test, so even if it is a function and it passes the vertical line test, if it fails the horizontal line test, then whenever we find the inverse, that inverse is not a function. Okay, and there is a few cases where that is true, like the parabola, for example. Okay, so that's basically all the theory for this one. So we're just going to jump in and do the examples, and then that should do us. So write down the inverse relation of x squared plus y minus 3 squared is equal to 1. Okay, so to write the inverse, what we're going to do is we're going to swap the x's and the y's around. So y squared plus x minus 3 squared is equal to 1. And that's it. That's the inverse relation. Graph the relations on the same number plane showing the reflection line. So if we start off with our line, with our Cartesian plane, we'll start off with the reflection line. So the reflection line is y is equal to x, and it's always y is equal to x when we're doing these inverses. Okay, so 1, 2, 3, 4, 1, 2, 3, and that's all we really need for this. Now, this is a circle. So let's start off by drawing our original, so graph the relations on the same number plane showing the reflection lines. Let's start off with our original one. So this one up here. X squared means that on the x's, we are on the origin. And our y minus 3 means that we're going to move our function up 3. So our circle with radius 1, I knew that was going to happen. Our circle with radius 1 okay, has center at x 3. So it's going to be the circle that goes here. Okay, now the inverse is, well, when y is equal to 0, so it's along the x-axis this time, but x minus 3. Remember, when we replace with x minus h, we're moving it that many spots. So we've replaced, so remember that y squared is equal, well, y squared plus x squared is equal to 1. If I replace x with x minus something, so 3's case, I'm moving it the number in that direction. So in this case, it's going to be here. Okay, and so my circle is going to come out here. Okay, and then they are there. So I've basically reflected it. So if you have a look, I've effectively reflected them over that line there, like that. Now, part C is to write the domain and range. So domain and range. And we'll do it for the first one. So x squared plus y minus 3 all squared is equal to 1. So that's this one that's up here. So that's my original function. So my domain for this one is all the values of x. So it's between -1 and 1. So -1 and 1, including those ones. And my range in this case is from 2 up to 4. So 2 to 4. Now for, sorry, right, 4. And now for y squared plus x minus 3 squared is equal to 1. Okay. What we're going to do is the domain and range. Now there's two ways you can do this, but let's do it the easy way. We know that for an inverse, the domain and the range just swaps. So domain becomes 2, 4, and the range becomes -1, 1. And just by looking at that, you can see too, along the x's, I've got 2 and 4. And along the y's, I've got -1 and 1. And that's it. So that's the domain for those ones. So last part D is the relation or its inverse a function? Neither are, because they both fail the vertical line test. Okay? And they're both circles, so, they both fail the vertical and the horizontal line test. So they're both many-to-many relationships. Anyway, that's that part. So let's have a look at example 2. Write down the inverse relation of y is equal to x cubed plus 3. So y is equal to x cubed plus 3. So the inverse is, swap them around, we get x is equal to y cubed plus 3. So the inverse relation is that. Now, let's, we can simplify that by simplifying the y as well, to make it y is equal to get the inverse function. So remove 3 from both sides, so subtract 3, you get x minus 3 is equal to y cubed. So y is equal to the cube root of x minus 3. So that is our inverse relation there. Now I didn't have to do anything with the first example because it was a circle and just swapping them around, like everything's on the left hand side anyway. But with this one, making y by itself so I can see whether or not it is a function or a relation. So, part B. Graph the relations on the same number plane, showing the reflection line. So what I'm going to do first is I'm actually going to graph the equation y is equal to x cubed plus 3. So we know that y is equal to x cubed plus x cubed is a cubic that goes like this. And if I have a plus 3 on the end, that just means that I'm moving up 3 spots. So my function looks like this. It's a cubic that's moved up 3 spots. Now my function, or my reflection line is y is equal to x, so it's going through like that. So basically what I'm going to do now is I'm going to reflect everything, but through that line. Now the easiest way to do it is look for the parts that are on the line, look for the parts that are equidistant, like that, and connect the points. So this one should actually go down to the 3 here. So remember the domain and the range is swapping. So all the x's become all the y's, is basically what's happening. So if something's passing through 3 on the y, it means it passes through 3 on the x. If something is passing through negative 3 on the y, or whatever that is, it's passing down here as well. Okay, so connecting up all of these points, like so, was going to give us a function that looks like, whoop, not like that. So this one's going to go through here like that. And it's going to go like that, something like that. In fact, it's going to come down and then shoot up, down and shoot across like that. So it should go like that, and it should start with, it actually passing through the correct spot. I can't even get these bloody graphs right. All right. So like that. That's better. So with that value there. Okay. So, and then basically if you turn your page around, it should just look like the opposite. And yeah, it looks something like that. So cool. Okay, so just putting the labels, that is y is equal to x cubed plus 3. And that is y is equal to the cube root of x minus 3. Like that. Okay, and you can see inside too, y is equal to the cube root of x should go through the origin. But if I replace the x with x minus 3, it means I shift everything to the right 3 and it goes through that point there. So that's another little cool tip or trick to help you with that. Okay, part C is to find the domain and range of both relations. Well, that's part C. So we're going to start off with y is equal to x cubed plus 3. Okay, x cubed plus 3. I'm going to start with the domain. Okay, the domain and the range. Okay, so the domain for this one is all real x, or if we're going to use our bracket form, it is our open brackets, negative infinity to infinity. Okay, and the range for this one is going to be all real y, so negative infinity to infinity as well. Okay, so it's going to make doing the range and domain of the other relation quite easy too, because we know that all we have to do is just swap them around. So the domain of the inverse is just the range of the original, and the range of the inverse is just the domain of the original. Like that, done. Okay, part D, is the relation or its inverse a function? Both are. As, and you can say it like this, so as the original is a 1-to-1 relation, i.e. passes the vertical line test, or vertical and horizontal line test. Show them how much you really know. Okay, so that's that one done. So one more example for us to do. Okay, so one more example. Example 3. Okay, consider the function y is equal to fx minus 2, where x is greater than 1. Write down the equation and condition for the inverse relation. Okay, so this is pretty easy again, as I said. So what we're going to do is we're going to write down our original, so y is equal to 3x minus 2. We're going to replace the y and the x, or swap them around. We're going to get 3x minus 2. No, not 3x, it should be 3y minus 2. And we're going to rearrange it. So we're going to get x plus 2 is equal to 3y, or y is equal to x plus 2 on 3. Okay, so there is our new function. But we need to add 2. So if this was x is greater than 1, then when we swap them around, it becomes y is greater than 1, where y is greater than 1, where y is greater than 1. Now, the problem is we don't want where y is greater than 1 for this. We actually want where x is greater than 1. So what we're going to do for part B is rewrite the inverse. Oh, I've screwed this one up because part A is just this bit here. Part B is then to rearrange it. Okay, so pretty cool. So we've done part B and changing the condition to restriction on x. So the restriction on x basically means that we want to change this part here to x. So how do we do that? Well, we've got an equation where y is equal to this, and we've also got where y is greater than 1. So what we can do is we can put these two things together, treat them like simultaneous equations. So y is equal to x plus 2 over 3, and where's y is greater than 1. So that means that if y is equal to x plus 2 on 3, but y is also greater than 1, then I can write x plus 2 on 3 is greater than 1, and we can solve it this way for x. That's all we have to do. Just put this is whatever to that number. That's it. And then solve it. So x plus 2 over 3 is greater than 1. So x plus 2 is greater than, well, times by 3, times by 3. So x plus 2 is greater than 3. Subtract 2, subtract 2. Well, turns out that when x is greater than 1 as well. And that's it. So that's how you change the restriction. That's pretty much everything for this topic or this lesson. So I shall see you guys for the next one.